Hello everyone, I'm Poonam Sharma, your science teacher. Welcome you again. Another session of science. Our chapter number 2 is matter around us pure. So students, in earlier classes we have covered classification of matter on the basis of their chemical properties. We have discussed few questions also, and we have discussed about elements, types of elements, how metals and non-metals are different from each other, how compounds and elements are different from each other, what characteristics do they have, what are mixtures, what are their properties, and we have discussed many questions based on these topics. In previous class, I have discussed about physical and chemical changes also. I explained difference between physical and chemical changes by giving few examples. So I hope that topic is clear to you. So we have already started with solution. This also I have explained what is solution and what it comprises of. As I told you, solution is a homogeneous mixture again, and it is a component of two things, solute and solvent, and that's why we call it binary solution. And in previous class, I have given example of solute and solvent by taking an example of water and salt, or you can take sugar, anything you can take. So this I have already explained. Types of solution we have covered so far. So if there is any doubt in these topics, you can ask while I am taking the class. So I'll just move on to the next topic. So before I start with concentration of solution, there is one term, that is solubility. Solubility. Solubility is the amount of solute dissolved in 100 gram of solvent, is known as its solubility. And every solute has a different solubility, different rate of solubility in a given amount of solvent at particular temperature. So how can we prove it? You can take an example of few solutes. For example, ammonium chloride, NaCl, sodium chloride, or you can take an example of ammonium chloride, NH4Cl, or you can take an example of potassium chloride, KCl, and dissolve all these solutes in a solvent, in a like 50 ml of water at 20 degrees Celsius. Now just note the solubility rate, and you will observe that these solutes have different rate of solubility in 50 ml of water at 20 degrees Celsius. Temperature is same, amount of solvent is same, but the rate of solubility is different. So we can say that every solute has different rate of solubility. And how can we define it? As I told you, the amount of solute dissolved in 100 gram of solvent is known as its solubility. So now there are certain formulas with the help of which we can find out solubility. First of all, if you need to find out the concentration of solution, so how will you find out? So formula for this is amount of solute upon amount of solution, or you can use this formula amount of solute upon amount of solvent and multiply by 100. And if you need to find out mass by mass percentage of a solution, so this formula will use mass of solute upon mass of solution multiply by 100. And if you need to find out mass by volume percentage of a solution, so in this case you need to use this formula, which is mass of solute and volume of solution multiplied by 100. So you need to learn these formulas for finding the concentration of solution, mass by mass percentage, or mass by volume percentage. So it depends on the question, whatever question demands. Accordingly, you have to use particular formula for this. Let's take an example of few numericals which are based on this. First is 100 gram of a solute is present in 550 gram of a solution. Calculate the concentration of solution. Now here mass of solute is given 100 gram and mass of solution is given 550 gram. So you need to find out concentration of solution. The concentration, how will you find out? So you'll use this first formula, this one, in which amount of solute is given and amount of solvent is given, or amount of solute or amount of solution. But in this question, these two are given. So we'll use this formula, mass of solute upon mass of solution multiplied by 100. And what is mass of solute? Which is 100 gram, and mass of solution is 550 gram, and multiply by 100. And then after solving this, it will be cut with this, then 1 upon 5, 5, and this 20. So our answer is 20%. So in this manner, we'll calculate the concentration of solution. Now question number 2 is to make a saturated solution. If you remember, I told you what is saturated solution. The solution in which no more solute can be added. That is known as saturated solution. It means that solution has a tendency to dissolve a particular amount of the solute. After this, we cannot add more solute in it and at a particular temperature. So to make a saturated solution, we need to add 36 gram of sodium chloride is dissolved in 100 gram of water at 293 Kelvin. So look here, 36 gram of sodium chloride, and solute always dissolve in less amount and solvent always present in more amount. So here we can say that this is a solute and water is a solvent here. So if we add 36 gram of solute, which is sodium chloride, in 100 gram of water, which is solvent at 293 Kelvin, so we need to find out the concentration in terms of mass of solution at this temperature. So simply we need to add both the amount of solute and solvent, and we'll get the mass of solution. So how can we do this? Look here. Mass of solute, which is 36, and mass of solvent, which is 100. Just add both the numbers, very simple, and then we'll get 136 gram. So mass of solution is 136 gram. So I hope this question is clear to you. Next question is, a solution contains 50 gram of sugar in 450 gram of water. One solution is there. We have this solution in which 50 gram of sugar is dissolved in 450 gram of water. So here again, water is a solvent. It's solvent and it is a solute. Okay. Calculate the concentration in terms of mass by mass percentage of the solution. So mass percentage of sugar, how can you find out? Mass of sugar, which is solute, is given 50. Mass of solution, just remember, mass of solution. And solution is a combination of solute and solvent both. So here, first of all, we need to add mass of both solute and solvent, which is 50 plus 450. This is solute, which is sugar, and this is solvent. When we add both these, it is 500. So mass of solution is 500. Okay. Now and multiply by this with 100, and then we'll get our answer like this. 10% is left. Okay, so it is mass percentage of sugar only. So mass by mass percentage, it means you need to find out the mass percentage of both solute as well as solvent. So in this manner, we'll get mass percentage of sugar and we need to find out the mass percentage of water. So it's very simple. Just minus this 10% with 100 and we'll get 90%. And from once you will get this answer, you can easily see whether your answer is correct or not, because the mass percentage of solute is always less than that of the solvent. So here mass percentage of sugar, which is a solute, it is merely 10%, and mass percentage of water, which is 90%. So in this manner, we'll get mass percentage of both solute as well as solvent. Okay, now we have suspension and colloidal solution. So these are different type of solutions in addition to true solution. So we have already discussed true solutions earlier. Like in true solution, the particle size is quite very small. We cannot see with naked eyes. It does not show Tyndall effect, and they are homogeneous. So, and it is very difficult to see the boundaries of the components which are present in a true solution, and that true solution is a transparent one. So here are different type of solutions. We have suspension and colloidal solution. So in suspension, if we are talking about suspension, the size of solute particles are visible. They are bigger than that of the true solution. So now if we are talking about this suspension, so the solute particles are quite bigger and they can be seen with the naked eyes, and they shows Tyndall effect. True solution doesn't show any Tyndall effect, but suspension show Tyndall effect, and suspension is translucent and the solute particles settle down. Being bigger in size, they settle down at the bottom. Okay, and the example of such kind of suspension are it's muddy water, paint, then milk of magnesia. So these are the examples of suspension. Just see this muddy water. Take water in a beaker, add some sand into it. You can see the particles of the sand are first rotate, then they'll settle at the bottom. Being bigger in size, they'll settle at the bottom of the beaker. And they shows Tyndall effect because they have some spaces between them. Now, if we talk about colloidal solutions, the size of solute particles are not visible with naked eye. They are quite small, but they show Tyndall effect, and they are translucent, and colloidal particles do not settle down. It means they remain suspended in the solvent. The solute particles remain suspended in it. And the examples of colloidal solution are blood. This is the example of blood, milk, smoke, and starch in water. Starch in water. So they remain suspended. So these are two other type of solutions. Now, if we are talking about colloidal solution, few terms are associated with this colloidal solution, and those terms are, we have electrophoresis. Second is coagulation. Now, what are these two terms? Electrophoresis. Electro, it means electricity involved in it. So these colloidal particles, the particles which are present in colloidal solution, they have tendency to move towards the ion, to move towards the anodes and the cathodes, and that's when the electricity passes through them. So they have the tendency to move or to rotate under the electric field. And that tendency of movement of particles of colloidal solution uh, when we are giving electric field inside the electric field, that is known as electrophoresis. And if we are talking about coagulation, the tendency of the particles of colloidal solution that they combine together to form bigger particles and then they settle. So it is known as coagulation. So colloidal solution has this tendency that it shows both electrophoresis and coagulation. And the movement of particles in the solution shows the Brownian movement. As I told you in previous chapter, when the particles follow zigzag path or they are moving randomly, that kind of movement is known as Brownian movement. So in colloidal solution, the particles can move randomly, and when they are moving, so under the electric field, under the influence of electric field, they can move easily. And that tendency of movement of particles in a colloidal solution under the influence of electric field is known as electrophoresis. And coagulation is when particles of colloidal solution combine together or bind together to form bigger particles. It is known as coagulation. So these are very important terms associated with colloidal solution. Now, if we talk about different type of solutions, see how they are different from each other. Now, let's see some properties of these different type of solutions: suspension, colloidal, and it is a true solution. So first of all, we'll take particle size. As I told you, the particle size in true solution is smallest one, and then in colloidal, and then in suspension. It means suspension has the biggest or the largest size particles present in them. If we are talking about filtrability means can we filter them? If we pass any of these solution through a filter paper, so what happens? Because it depends on the size of the particles. True solution can easily pass through the filter paper because the size of particles are very small, and it can easily pass through the filter paper. But if we are talking about colloidal solution, they can pass through filter paper but not through membrane. Here membrane means the cell membranes, the membrane which is present in the cells. And if you are talking about suspension, they cannot pass. If you take muddy water and try to filter that muddy water with the help of filter paper, that mud starts deposit, or it leaves as a residue on the filter paper, and the solution and the solvent is left behind. It goes in the another beaker. So in suspension, so it cannot pass through. If we are talking about settling of particles, in true solution, because of the size of the particles, they'll not settle. They'll remain in the solvent only because it's a homogeneous mixture. Although these are also homogeneous. If we are talking about colloidal, they settle only by a particular method, and that is centrifugation. We'll discuss this method later, how this centrifugation method helps to settle the solute particles. Then suspension. They settle on their own. They don't need any particular method. For example, if you take sand and water, sand being heavier in size, it settles on its own. If you leave it for some time, it settles at the bottom. And if you're talking about the appearance of these different solutions, now this suspension is opaque one. Colloidal solution is generally transparent, and solution is completely transparent, or colloidal sometimes it's translucent also. And Tyndall effect. True solutions does not show because size of particles are very small and they are very close to each other, so they do not allow the light to pass through them. But if you are talking about colloidal and suspension, they show Tyndall effect. Now, how the particles diffuse, it means how they mix together. And in true solutions, the diffusion of particles, the mixing of particles, it takes place at a very fast rate. And in colloidal, the rate of diffusion is quite slow. In suspension, they do not diffuse, they do not mix, because the particle size is quite entirely different. Then Brownian movement in true solutions, they may show, because size of particles is quite very small, and but colloidal particle solution, they show this Brownian movement, because the size of particle is not that much small or not that much bigger, it is intermediate. And suspension, sometime it shows, sometime it will not show, or because they'll get very less time to show this Brownian movement, they come and settle at the bottom. And if you're talking about the property, true solution is homogeneous, and colloidal solution is hetero, and suspension is also heterogeneous. Now, if you're talking about these properties of different solutions, so these are the properties on the basis of which we can easily differentiate these three different type of solutions, which is suspension, colloidal, and true solution. So in exam, question can come on the basis of their properties. You can easily differentiate them, or sometimes question can come on particular property, so you have to mention that property only. Now, continuously I'm talking about Tyndall effect. There is very common term which I'm using, this Tyndall effect. Tyndall effect is the scattering of light by particles. And when the light passes through the particles, if it allows the light to pass through them, this effect is known as Tyndall effect. And it only takes place when the size of particles are not very small or not very big. Because if the size of particles are quite very small, so they are very close to each other, so they hardly get any space which allow the light to pass through them. So that's the reason why true solutions do not show this Tyndall effect. And if we are talking about suspension, the size of particles are quite very big and they immediately settle at the bottom, so they do not the light will not get chance to pass through them, and only very little time is left for the light to pass through it. But if you are talking about colloidal solution, the particles, the solid particles remain suspended in this solvent, and as a result, light will get sufficient time to pass through it. So that's why it shows Tyndall effect. And if we observe this Tyndall effect in our daily life, we can see this effect in forest, in the canopy of the forest. Canopy is the outer layer of the forest. In dense forest, tall trees are there, and due to the presence of these tall trees, their leaves form umbrella type structure, and between the leaves there are some spaces. Through those spaces, light can easily pass. Then this effect is known as Tyndall effect. Now, what kind of question can come in exam on the basis of this topic? First is, what is Tyndall effect? Name two mixtures which shows this effect. As I told you, Tyndall effect is the scattering of beam of light, or when the particles allow the light to pass through them. So that effect is known as Tyndall effect. An example of such kind of mixtures are when dust particles suspended in air. In your room, light can easily enter through the window. If some open area is there in the window, light can pass and you'll see dust particles in that beam of light. So that is an example of Tyndall effect. And Tyndall effect can show in starch in water. You can take this example, or you can perform this activity at home. Just take a glass, fill water into it, or starch water. Then add some starch into it, or you can use the starchy water. When you prepare rice, that water which comes from the rice, when you boil it, that contains starch. So if take that water and pour that water in a beaker and take this torch and allow the switch on this torch and allow the light of this torch to pass through it. You will observe that light can easily pass and reaches to other corner. So you can perform this activity in dark room also, and you can see the effect of light on the other side of the wall or other side of the beaker. So this shows that colloidal solution shows the Tyndall effect. So you can perform this activity and you come to know what is Tyndall effect, how you can show this Tyndall effect in colloidal solution. Or you can perform this activity by taking different solution. Take salt solution. Add salt in water and try to perform this same activity through the salt solution. So these are the examples. Or you can perform this activity by taking an example of muddy water. Then you can easily see out of these three, only colloidal solution, which contains starch water, it allows the light to pass through the or scatter the light. Then we have another question. State which of the following solutions exhibit Tyndall effect. Starch solution, sodium chloride solution, tincture of iodine. Now children, tell me what is tincture of iodine. The tincture of iodine means when we dissolve iodine in an alcohol. So here solvent is not water, it's an alcohol. So when we add iodine in alcohol, we call it tincture of iodine. So we have different solutions. Starch solution, sodium chloride solution, which is NaCl solution. That we are simply adding salt, which we are consuming on daily basis, and then you mix that salt in water, it becomes sodium chloride solution and tincture of iodine. Now we have these three solutions and air also. Now Tyndall effect is shown by both starch solution and air. Just now I have explained to you that starch and air, they both are colloidal solution. They both come under the category of colloidal one, because the size of the particles which are present in them, it's quite intermediate. They have enough spaces which allow the beam of light to scatter or to pass through them. That's why only these two shows Tyndall effect. Otherwise, sodium chloride, which is a true solution, or tincture of iodine, they do not, and which is also a true solution, does not allow the light to pass through them or scatter through them. So only starch and water allow this Tyndall effect or perform this Tyndall effect. Now if we are talking about colloidal solution, colloidal solution always contains two phases, dispersed phase and dispersing medium. Dispersed phase means the solute part, the components which are dispersed, which are present or suspended in the solution, that is known as dispersed phase. And dispersing medium, in which those solute particles are present, we call it dispersing medium. So we have two phases in a colloidal solution, dispersed phase and dispersing medium. For example, starch in water. Starch in water. So here starch is a dispersed phase and water is a dispersing medium. So colloidal solution always contain two phases, dispersed phase and dispersing medium. And depending upon these phases and the medium, colloidal solutions are of different types. What type of colloidal solutions we have? Look at the examples. If dispersed phase is liquid and dispersing medium is gas, this type of colloid or colloidal solution is known as aerosol. And examples of such kind is fog, clouds and mist. Second is solid. Dispersed phase is solid, and if dispersing medium is gas. So here you can see colloidal solution is composed of two phases, dispersed phase and dispersing medium. So depending upon those phases and the mediums, we have different type of colloids. If solid and gas is present, we call it aerosol. An example of such kind of colloids are smoke, automobile exhaust. And next is, if dispersed phase is gas and dispersing medium is liquid, then this type of colloid is known as foam. An example of such kind is shaving cream. Another type of colloid is when dispersed phase is liquid and dispersing medium is liquid. It means they both are liquids. So that's known as emulsion. Example is milk and face cream. Creams which we are using to on a daily basis on our face. And if dispersed phase is sodium and dispersing medium is liquid, this type of colloid is known as solution. And the example is milk of magnesia and mud. Then if dispersed phase is gas and dispersing medium is solid, then this type is known as again foam. An example is sponge and pumic stone. We use pumic stone to remove dead skin from our body. So that pumic stone also has some pores. So sponge also has some pores in it. So gas and solid, these two when combined together, they form a foam type of colloid, and the examples are sponge and pumic stone. Then if we have dispersed phase liquid and dispersing medium is solid, then we call it gel. And examples of such kind is jelly, cheese, butter. These are the examples. Now another dispersed phase example is sodium. And if dispersing medium is again solid and solid, then we call it solid salt. And the example of such kind is colored gemstone and milky glasses. So as you can see, if dispersed phase or dispersing medium are different, we'll get different type of colloids. And examples of such kind of colloids are in front of you. So just learn these examples along with dispersed phase and medium, because generally this question comes in 1 mark. Identify dispersed phase and the medium in the given example, or identify which type of colloid is this. So you need to write this, which phase is this, which medium is present, what type of colloid is it, and example. So you need to learn this. And there are certain applications of colloids. So where we are using colloids in sewage disposal, in medicines we are using, in sewage disposal, then medicines and smoke precipitators, as I told you, in automobile exhaust. So these are the applications, or we use colloid in the production of rubber. So these are the applications of colloidal: production of rubber, sewage disposal, medicine, smoke precipitators. So these are the applications. I'll just write here applications of colloids. Applications of colloids. Now, these are the properties, and how can we differentiate this? I have already discussed with you. I'll not discuss it again. Now, what kind of question can come on the basis of this topic? List any 3 differences, 4 differences, 5 differences, 1 difference, anything. Any in this question can come in any form. So when this question come in exam, so you need to write the difference between these 3 different solutions, and it's a frequently asked question. So you need to learn this table, which I have already explained to you. So you can choose any property if it is not mentioned in the question. Like in this question, it is not mentioned which on what property, on basis of what property you will differentiate different type of solution. So you can choose any property. But if it is mentioned that on the basis of particle size or appearance or Tyndall effect or diffusion of particles, then you need to write only that particular point. And the next question is, on dissolving chalk powder in water, a suspension is obtained. Give any 4 reasons to support the fact that mixture so obtained is a suspension only. So when we dissolve chalk powder, a suspension is obtained. So that chalk powder, when you mix it in the water, it will settle at the bottom. It will not mix up completely. It remains suspended, then it settles down. So, and this property shows that it is a suspension. And if you try to filter this suspension or this solution through a filter paper, you'll observe that the chalk powder remains in the filter paper and the solvent, the water, passes through it. So on this basis, we can say that yes, it is a suspension. So I hope till here it is clear to you, and just revise it whatever I have taught you today. So in next class I'll continue with the same chapter. So till then, bye and take care. Just go through all the topics whatever we have discussed so far, so that it will be easy for you to understand the next topic. So thank you everyone. These are the topics which we have covered today. So these questions we have discussed today on the basis of solubility and difference between different type of the solution.